Hello everyone, welcome back to our channel. Let's see the next reaction, that is Shapiro reaction. In the last video we discussed about the Bamford-Stevens reaction. Shapiro reaction and Bamford-Stevens reaction both are similar kind of reactions. The statement of both the reactions will be same. The base catalyzed conversion of tosyl hydrogens of carbonyl compounds into alkenes. In Shapiro reaction and Bamford-Stevens reaction, the products are same. Alkenes are produced. But in case of the Bamford-Stevens reaction, what happens? The more substituted alkenes are the major products. But in case of Shapiro reaction, the less substituted alkenes are the major products. So you need to remember whenever you study both these reactions. Right? This is the first point. If you see the mechanism, in case of the Bamford-Stevens reaction, the carbene intermediate is formed. But in this case, we are not going to observe any kind of the carbene intermediate. The general equation is same. The mechanism is different from the Bamford-Stevens reaction. In case of Bamford-Stevens reaction, what happens? We have used the base, but the number of moles of base used is only 1 mole. In case of Shapiro reaction, we have changed the base, that is alkyl lithium. Here the number of moles are going to be 2 moles. This is very important point you need to remember in case of this Shapiro reaction. Already we know that the activity of the base can easily remove the proton. So we have used 1 mole of base, that is used to remove 1 proton. But here we are using what? 2 moles of base. That's why what happens? This base will remove 2 protons. If you see the mechanism, what happens? The first mole is going to remove the hydrogen attached to the nitrogen. The second mole is going to remove the hydrogen which is connected to the carbon. So we are going to remove 2 hydrogens. That's why carbene ion and also the nitrogen containing an anion. 2 anions are produced in case of the Shapiro reaction. Why? Because we are using 2 moles of the base. Okay. Now what happens? The carbene ion is going to involving in the delocalization. Thereby what happens? The removal of tosyl group takes place. It can generate what? Carbon-carbon pi bond and nitrogen-nitrogen pi bond. Generally, we know that if you have 2 nitrogen atoms which are connected to each other, at the ending of this stage, they are going to be removed in the form of nitrogen molecule only. That's why what happens? The minus charge again form a triple bond. Then the carbon-nitrogen bond is going to have the cleavage. Thereby, we are going to have C minus. So C minus, and in solution we are having Li plus ions. So that will attach to the carbene ion. If you observe the RLi, initially what happens? We have removed 2 protons or not? 2 H plus ions we have removed. Alkyl lithium RLi, the representation is what? R minus and Li plus. So if you use 2 moles, 2 R minus ions and 2 Li plus ions. 1 R minus approaches to H plus to form RH. Second R minus and second H plus to form RH. So 2 moles of hydrocarbons will be removed and we are having Li plus ions in the solution. So one of the Li plus ion reaches to what? This carbene ion. If this product is subjected to hydrolysis, what will happen? We will come up with alkenes. If you observe this particular species, it is also a kind of RLi or not? It is also a kind of RLi. See this one. If you assume that this is R and Li plus, that is also RLi or not? Organolithium reagents. It is very important topic. In coming series of videos, I am going to explain the importance and applications of RLi, alkyl lithium or aryl lithium in the organic synthesis. Right? So this is the what? Mechanism of Shapiro reaction. If you see the applications, the first application is what? A cyclic ring containing the carbonyl group. Initially what happens? It is going to treated with tosyl hydrazine. The tosyl hydrazine initially produces what? Tosyl hydrazone. It means the reactant is going to be produced that is subjected to treatment with butyl lithium. So 2 moles we are going to remove, thereby we are coming up with what? This particular moiety. Suppose if you have the substitution at the alpha position, what will happen? The alkene may be formed here or the alkene may be formed in this way. Already we know that the Shapiro reaction is useful to synthesize the less substituted olefins. That's why the product is going to be this one. Okay, this is all about your Shapiro reaction. Let's see the differences between Bamford-Stevens reaction and the Shapiro reaction. Here the first one is what? The reactants. In both the cases are same. Okay. The second one, here the product is more substituted alkene, here the product is less substituted alkene. Why? Because it is kinetically controlled reaction, it is thermodynamically controlled reaction. The third point, the basis which we are using in Bamford-Stevens reaction is sodium methoxide, sodamide, sodium hydride and sodium in ethylene glycol. In Shapiro reaction, the used base is what? Alkyl lithium. But here we need to identify and remember one thing. In case of the Bamford-Stevens, we need to use only 1 mole of the base. In case of Shapiro reaction, we are going to use 2 mole of the base. So in this way, you need to remember both Bamford-Stevens and Shapiro reactions. Okay.